Hi everyone, welcome to lesson 21. We are looking at operations with radicals, and it's exercise 4b.1 from your textbook. So what we're going to be concentrating on in this very short lesson is adding and subtracting with radicals. Now, if we were to do 4a plus 5a, what we would end up doing is we would end up collecting the like terms. So let's just take some regular examples with variables. So I have 4a plus 5a, and I see that I have the same variable, and therefore, because the variable is the same, then I can collect my like terms and say that 4a plus 5a equals 9a. Now, if I want to add or subtract radicals, I'm doing basically the same thing. I am collecting like radicals. So I'm collecting to see where the like square roots are. So the ones that are the same get added together. The ones that are not the same don't get added together. So for example, 4 root 3 plus 5 root 3 ends up being equal to 9 root 3. So it does not become 9 root 6. What's under the square root does not get added up. Only what is outside of the square root, very much like when we say 4a plus 5a. So the 4 and the 5 add up, they go to 9a. We don't say that it goes to 9a squared. Okay? So the same thing occurs. Let's see if we do the second example. So we've got 4a plus 3b minus a plus 6b. So again, what we are doing is we're collecting like terms. So if I had to do this addition and subtraction, it would be 4a plus 4a minus a gives me 3a, and positive 3b plus 6b gives me positive 9b. So if I do the same thing in this problem here, I collect my like terms. There's my root 2, there's a root 2, and we've got a root 5 and a root 5. Therefore, I add 4 root 2 minus 1 root 2, plus 3 root 5 plus 6 root 5, and we end up getting 4 minus 1 is 3 root 2, and then 6 plus 3, it gives us plus 9 root 5. Notice that the square roots, what's under the square root, root 2 and root 5, they do not change in any way or form. They stay as they are. All right, let's take a look at a couple of examples. So we've got 3 root 3 minus root 2 minus bracket 1 minus root 2. Okay. So that we have 3 root 3, well that can't be simplified in any way, so 3 root 3 minus root 2. Now because I have this minus in the front of the parentheses, that means that everything inside the parentheses changes its sign. So it goes to minus 1 plus root 2, and therefore what we do now is we say, well, 3 root 3 doesn't have anything that matches with it. There is no like term or like radical. So 3 root 3 will stay exactly the way it is. But then we've got negative root 2 plus root 2 that cancel themselves out. And so I'm left with simply a negative 1. If we now look at the next example, I've got a root 7 and a root 7. So I can do root 7 plus root 7, collect those like radicals. And then I collect the other like radicals, which are here and here, root 2 and root 2, so that I have minus 2 root 2 minus 1 root 2. And therefore, this goes to 1 root 7 plus 1 root 7 is 2 root 7. And then minus 2 root 2 minus 1 root 2 gives me minus 3 root 2. So technically, this is as if I were saying x minus 2y plus x minus y. So it becomes 2x minus 3y. Nothing has changed. I have the same coefficients. All that's changing is my variable. Instead of having x and y, I've got root 7 and root 2. Okay. Now, the only other examples that I'm going to show you in terms of adding and subtracting are examples where it seems like we don't have anything that we can add or subtract. So when that situation occurs, if we have unlike radicals, So in other words, like root 32 plus root 72, neither of those could be added together. But because we can reduce these down to simpler terms, so reduce to simpler terms, we might be able to find like radicals in doing so. So let's try doing root 32. So we can reduce root 32 to root 16 times root 2. And if I take root 72, well, the highest factor there, and it's plus, so I've got to remember there's a plus in between, and root 72 is like having root of 36 times the root of 2. Now the root of 16 is 4, and what's left over is root 2, plus the square root of 36 is 6, and there's a root 2. I now have like terms. 4 root 2 plus 6 root 2, which equals 10 root 2. So we have now like terms, or like radicals, and it goes to 10 root 2. If I do the second example, I have, again, reduced to simpler terms. So I will say, starting with root 18. So root 18 could be broken down into root 9 times root 2. Minus root 72, we already saw in the previous question, is, we'll put the minus right here, is minus root 36 times root 2, and then it's minus root 8, which is like saying minus root 4 times root 2. So I'm just dividing these all up, I'm just putting them properly. Okay, so the square root of 9 is 3, and we get 3 root 2. The square root of 36 is 6 root 2, but there's a minus in between. And the square root of 4, root 2, the square root of 4 times root 2 is minus 2 root 2. So I end up getting 3 minus 6 is negative 3. Negative 3 minus 2 gives me negative 5 root 2. There's my final answer. All right, that's it basically for this lesson. You will be responsible only for completing the exercise 4B.1, all of it, in the textbook, in the MYP4 book. See you next time.